Chapter 5, Section 1 is going to cover the midsegment theorem. So we're going to find out what the midsegment is and the theorem about it. So we start with the definition of a midsegment. The midsegment is a segment that connects the midpoints of two sides of the triangle. Every triangle has three midsegments. So if I start with my big triangle, I can pick any two sides. So if I pick the left and the right, and I find the midpoints of those sides, so I know these are the midpoints because of these markings and these markings, and I connect those two, that MP is a midsegment. If I look at the other two, if I pair another two sides, so if I say this side and this side, I find their midpoints, which would be here, and connect them, and P is also a midsegment. And then if I pair my last two sides together, this one, and I locate their midpoints, which would be here and here, and connect them, again, MN is also a midsegment. The midsegment theorem says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So in this diagram, they just drew one of the midsegments, but again, there'd still be three. In this segment, DE is the midsegment. And so what we know is that if DE is a midsegment, then in this case, it is parallel to the third side, the side it's not intersecting with, which would be AC, and DE is 1/2 the length of that third side. A coordinate proof is a proof by placing geometric figures in a coordinate plane and then using variables to represent the coordinates of the figure, and the results are true for all the figures of that type. So we're going to overlap or draw shapes on coordinate grids and then prove certain things about that shape. So if you haven't done so already, you're probably going to want to download a coordinate grid from Google, save it in your camera roll so that you can access it and pull it in to plot these kinds of questions. All right, so example 1 says triangles are used for strength in roof trusses. In the diagram, UV and VW are midsegments of triangle SRT. Find UV and RS. So in this triangle, which is SRT, it's saying that UV is a midsegment, which means it intersects this side at its midpoint, this side as its midpoint. It also means it's parallel to this side and half its length. So if the length of the large side is 90, then that means UV would be 45, or half its length. This time it gives you a unit, so it's 45 inches. Then it says that VW is also a midsegment. So if this is a midsegment, it means, again, this is congruent to this, which you already know, and this is congruent to this. This midsegment is parallel to SR, and it's half its length. So this time I want SR or RS, which is the big side, and they know the half. So I'm going to take that 57, I'm going to multiply it by 2. And I get that RS is 114 inches. Example 2 says, given R, S, and T are the midpoints of the sides of triangle ABC, complete the table. So if they're midpoints, then this is congruent to this, this to this, this to this, this to this. Which means ST is a midsegment, RS is a midsegment, and RT, they're all midsegments. So for A, which is running this way, A tells you AB is 12. This whole side is 12. BC, this whole side here, is 14. And AC is 18. So it's giving you all the lengths of the larger triangle, which means when I go to find the midsegments, which is what it's asking for, ST, half the length of this side, If that side is 18, then ST is 9. RT, which is here, half the length of this whole side. That whole side is 12, so that's 6. And RS, half the length of this whole side here, which is 14. Half of 14 is 7. Now we're going to clear all that off because we're going to get new values. Okay, in B, which is here, they give you BC, which is this side, is 15. AC, this side, is 22. And RT, which is here, is 10. We're still using the mid-segments, but now we know that AB would be twice what ST is, or ST is half, or sorry, AC, sorry. AC would be twice of ST, so ST would be half of 22, which is 11. AB is this side, is twice the mid-segment here, which is 10, so that's 20. And RS, which is this mid-segment here, is half of this 15, or 7.5, or 7.5. Okay, and then the last one, again, we'll clear it off so we have our new measurements. AB is 10. ST is 9. And RS is 7.8. So if I want to know BC, which is this side, I'm going to take 7.8 and double it. $15.6. If I want AC, which is here, I'm going to take the mid-segment, which is 9, and double it. That's 18. And if I want RT, which is here, now that's the mid-segment, so I'm taking the 10, dividing by 2, and I get 5. Example 3 says, place a rectangle in a coordinate plane so that its vertical side has a length of A and its horizontal side has a width of 2A. Label the coordinates of each vertex. So I'm going to pull in a coordinate grid. And it doesn't matter where you plot it. So if I plot my first point here, and I want my vertical side to be half the length of the horizontal. So whatever I make the horizontal, let's say it's here, this side is 2A. And because I made it 6 units, I'll go up to the 3 units. This side is A. And you can make that any length you want as long as the horizontal is double the vertical. So then because this is not coordinate specific, when it says label the coordinates, we're going to say that this point is 0, 0. This point, we went to the right 2A, but didn't go up or down at all, so it's still 0. This point would be 2A and then up A, and this point would be 0 and A. Now, depending on where you move it around, the A should always be at the top, and the 2A should always be at the bottom. Example 4 says, sketch triangle ABC. Find the length and the slope of each side. Then find the coordinates of each midpoint. Is ABC a right triangle? Is it isosceles? So again, we're going to pull in a coordinate grid just so that we can see what this would look like. This says A is 0, 0. So the first coordinate point is given as 0, 0. Then HH is B. So you're going to the right a certain distance and then up a certain distance. So let's say we go to the right 4 and up 4. This would be B, which is HH. And then C is 2H and 0. So this time I'm going double the length of the H, which I did 4, means I'm going to go to 8. And this would be 2H, 0. So there's my triangle. Then it says find the coordinates of each midpoint. So I need to find the coordinate here, here, here. If you don't know, like if this is an equal distance, so I can just find it from the graph, but if I didn't know that, then I would need to find the midpoint of each one. So the midpoint of AB, remember midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So A was 0, 0, B was h. This would be 0 plus h over 2, 0 plus h over 2. And I'd get h over 2 and h over 2. Then I want to find the midpoint of BC. So this is the midpoint of AB. Midpoint of BC would be h plus 2h over 2 and h plus 0 over 2. 3h over 2 and h over 2. And then the midpoint of AC would be 0 plus 2h over 2 and 0 plus 0 over 2. So 2h over 2, 0 over 2, which is h, 0. Now, what I could have found before was the length of each side. So from this side, I'm going to find the length between 0, 0 and h, and I'm going to use the distance formula. So this is midpoint, and then distance x2 minus x1 squared plus y2 minus y1 squared. So I'd get h minus 0 squared plus h minus 0 squared, h squared plus h squared, which is 2h squared underneath the square root. So I can take the h out. That would be h square root 2. That's AB. Then I want to find, so AB. Then I want to find BC. So now I've got h, and then 2h, 0. So 2h minus h squared plus 0 minus h squared. This is h squared plus negative h squared plus h squared, or 2h squared, which again is h root 2. That's BC. And then the last one is AC. And this one you can actually count because it's horizontal from 0 to 2h. This is 2h. Then it asks for the slope of each side. So remember, slope is rise over run, or y2 minus y1 over x2 minus x1. So the slope of AB could be rise over run, or find that slope using the equation h minus 0 over h minus 0, which is h over h, or 1. The slope of BC is 0 minus h over 2h minus h, negative h over h, which is negative 1. And AC, which is horizontal, or 0. Again, you can find it using 0 minus 0 over 2h minus 0, 0 over 2h, which is still 0. Now comes is it a right triangle? So remember, to see if it's a right triangle, you would compare the side lengths, or the slopes. I've got 0, 1, and negative 1. These two are opposite reciprocals of each other, which means AB is perpendicular to BC. So it is a right triangle. And the last question says, is it isosceles? For that, I need the lengths. So AB was h root 2, BC is h root 2, and AC is 2h. There are two sides the same, so it is isosceles. Okay, example 5 says use triangle GHJ, so I don't know what it looks like, GHJ, where A, B, and C are the midpoints of the sides. And it says GH, this one here, is 7x minus 1, and BC is 4x minus 3. What's GH? So remember, the relationship is that 2 times this equals this. So 2 times 4x minus 3 equals 7x minus 1. 8x minus 6 equals 7x minus 1. Subtract the 7x. Add the 6. And x equals 5. So then we plug it back in to find GH. So 7 times 5 minus 1 is 35 minus 1, or 34. And that's the length of GH. Okay, that wraps up the mid-segment. Your assignment is on Canvas.